Okay, the following is a video about inverse trigonometric functions, and the main thing that I want you guys to see here is that this allows us to find angle measures, okay, which is pretty cool if you ask me, but you probably wouldn't do that. So in any case, one thing I want to do is I want to locate this angle x here, okay? This is a right angle, this is my opposite side, my adjacent side, and my hypotenuse. Now, all an inverse trig function does allows us to find the angle measure. So if I write out my standard trig ratio, and if I say sine of x degrees, then that's going to give me my opposite side divided by my hypotenuse, right? Remember, we have SOHCAHTOA or SOHCAHTOA. So what an inverse does, okay, so this is just a regular function. What an inverse does is it switches these values, okay? It switches my input and my output, and we switch them with each other. So what I can do then is if I wanted to write this as an inverse, I would say sine inverse, and I denote that by raising it to the -1 power. So sine -1 of the opposite side over the hypotenuse is equal to x degrees. Okay, and we're going to use this quite a bit, but that's all I'm doing. Okay, if you can write out your trig function using SOHCAHTOA, okay, you should write this down on every sheet of paper that you use when you use trig. If I can write this, then all I got to remember is to switch those values, and that's what we get for our inverse sine function, okay? So now let's do the same thing but for cosine. We're going to call this our right angle. We'll call this the opposite side, the adjacent side, and the hypotenuse. And we're going to call this angle x degrees. So what I can do is I can write cosine of x degrees is equal to the adjacent side divided by the hypotenuse. Okay, now if I wanted to do my inverse and find my angle measure, well, I just switch my input and output. I switch the x and the a over h. So I would write it like this. I would say cosine inverse of a over h is equal to x degrees. Okay, so I can solve for x that way. Okay, if I did it for this or if I did it for this, I would still get x as a result, whatever that is. All right, so now let's do it for tangent. Okay, and so what I would want to do here is I have my right angle, I have my opposite side, my adjacent side, and my hypotenuse, and this is angle x, okay? Now, if we know our regular tangent function, so tangent of x is equal to the opposite side over the adjacent TOA, okay? So in order to find what x is, given those side lengths, I would take my x and my ratio and switch them, but I would put it into my inverse function. So tangent of -1, or inverse tangent of opposite over adjacent is equal to x degrees and allows us to solve. Okay, so pretty powerful stuff. And you'll see that they have those buttons on your calculator. I'll show you those here in a second. But let's take a look at one of our examples. Okay, in this example, it says solve a right triangle. Basically, find all of the other angle measures and side lengths of this triangle that are given. Okay. So what I'm going to do is, it doesn't really matter what we do. I'm going to find angle R first, okay? And so I'm going to call this X. I'll call this angle over here Y, okay? And then I will call this segment length over here Z, okay? Doesn't really matter. But if I wanted to find X, okay, given a right triangle, I'm going to use my cosine function because given angle x, this is my adjacent side and my hypotenuse, okay? So for x, if I said this, if I said cosine of x is equal to the adjacent side over the hypotenuse, so it's equal to 5 over 5.7, okay? So now what I would want to do in order to solve for x, in order to find out what that is, I would want to use an inverse. And so I'd want to do this. I would want to write cosine inverse of 5 over 5.7 is equal to x degrees. Okay, so let's go to our calculator and plug that in. So if we come over here to our calculator, I would do, okay, so cosine is the blue one above, or cosine inverse is the blue one above cosine button. So I want to hit the second button and then cosine. And what did we have? 5 divided by 5.7, so 5 divided by 5.7. Close my parentheses. Look at that. That's what that angle is. It's about 28.69 degrees. We want to round that to the nearest degree, so we're going to go ahead and round that to 29. All right? So what I know after just plugging that in the calculator, I can then say that x degrees is equal to 29 degrees. Okay? Pretty powerful. So I'm going to come over here, and I'm going to call this 29 degrees. All right? So it was x, and it's equal to 29 degrees, okay? So now we've got a number of ways to find what y is. Now, if I really wanted to find what y is, I know it's just going to be 180 minus 90 minus 29. So let's go ahead and figure out what it's going to be, and then I'll show you how to find it using trig. So 180 minus 90 minus 29. Okay, and that's going to give us, what is that, 61? All right, so we know what we're going to get here. We know that y is going to be 61 degrees. Okay, so, but look, you know, if I'm talking about y, then I've got a different trig function that we're using now. This is no longer the adjacent side. This is still the hypotenuse, but let's rename them as the opposite side now and the hypotenuse. So since I'm using opposite and hypotenuse, I want to say this. I'm going to say sine of angle y degrees, is equal to 5 over 5.7. Okay, same ratio actually, but just using sine, so it's a little bit different. So now I want to do this. Okay, if I wanted to solve for y, I would use my inverse, and I would say sine inverse of 5 divided by 5.7 is equal to y degrees. Okay, so let's go to our calculator and let's figure out what that is. So I want to do second sine, give me sine inverse of 5 divided by 5.7. Close my parentheses, hit enter. Oh, look at that. If I round that, I'm going to get 61, folks. That's pretty slick. So let's write that. Let's write that y is equal to, okay, 61 degrees. And we knew that just because of our knowledge of triangles, but also we wanted to, we could use it using trig. Okay, so now let's find z. Okay, let's find this side length z. Number of ways we could do this, guys. Let's go ahead and just use angle R for right now. Now, what I know here, if I use angle R, let me switch this up a little bit. I know that angle R is 29 degrees. So I know that this is my opposite side and my hypotenuse. Okay. You could use any number of trig functions here. You would have to use either tangent, because you have the adjacent side, or you have to use sine because you have the hypotenuse. So what I could do here, let's just go ahead and use sine of 29 degrees is equal to z, the opposite side, divided by h, which is 5.7. Okay, so if I want to solve for z, I did what we did before in the other video, and I multiply both sides by 5.7, multiplied by 5.7. Whoops. Multiply by 5.7. So I end up getting this. I get that z is equal to 5.7 times sine of 29 degrees. Okay, so let's plug that into our calculator. Let's see what we get. I'm going to do 5.7 times, what was it, sine of 29? So sine of 29 degrees. Close our parentheses and look what we get. We get 2.76. That seems reasonable to me. So for Z, we get a length of 2.76, round to the nearest hundredth. So it sounds about right. So 2.76. Okay. And we'll stop this and we'll do a different video.